Uh, does anybody want to look at any homework questions?
Let's see.
Are we good or are we waiting?
Okay.
Can you go over number 6? Or no, not number 6. Yeah, number 6.
In which assignment? The fact.
The P6 assignment.
Okay. It's taking its time today.
Okay.
Question number 6 asks you to do the division and to decide which values need to be excluded. In order to do the division, first of all, to decide what values need to be excluded, I'm looking at the denominators that I have. That decision, what needs to be excluded, again, we're talking about the domain, and that's where we start looking at what makes it undefined, where the denominator is 0. So that first denominator, I'm worried about where does, oh no. Where does, there we go. Where does that denominator x minus 3 equal 0? And that gives me x equals 3.
So
go ahead.
So you figure that out before you do anything else? You figure out,
with a division problem, honestly, don't get too mad at me. You have to do it twice. So
okay.
We have to worry about what makes the other denominator equal to 0. And
okay.
so that factors into x plus 3, x minus 3. And so from that, we get that it's 0 when x equals negative 3. Then we got to rewrite it as a multiplication problem. 10x squared plus 15 over x minus 3. The division becomes multiplication, x squared minus 9 over 6x squared plus 9. And then we have to worry about where does this denominator equal 0. And so when I look at where does the 6x squared plus 9 equal 0, there's a common factor of 3, which leaves me with 2x squared plus 3. And now I don't think that factors because it's 2 terms, it's addition. They're not cubes, so that's not going to factor. So this one doesn't give me any additional values to exclude, but some.
Okay.
So we're going, x cannot equal negative 3 or positive 3. And then from here, are you all right with the rest of the problem, finishing it by factoring?
Yeah, I am.
Okay, great. But when with the
what confused me was like I did some of the homework and it said I didn't get all the numbers that needed to be excluded. I missed those. I didn't know how to get how to get those. So
those that come from looking at the domain, and the values that you exclude are the values that give you a 0 in the denominator. What you have to be careful of with the division problem is this cannot be 0, this cannot be 0, and also after you flip it, you still can't have a 0 in the denominator. So
you have to figure out before and after the numbers that are excluded?
And after you flip, right.
Oh, okay.
Okay.
So 3 parentheses 2x squared plus 3, can we figure out what's the number excluded from that one, or is that just when you factor it?
No, that one, when we set it equal to 0, you don't get any answers. That's not factorable. So
Okay.
that one we don't have to worry about.
Okay.
Okay?
Mhm.
All right, better?
Yep. Thank you.
Anybody else want to look at anything from this homework? If not,
Can you do question 11?
I hope so.
Also, real quick, if you're screen sharing, it's not appearing for me.
Oh, is the screen appearing for everybody or no?
I
can
just
see
like
it.
I can see you, but I don't see your screen sharing.
Okay, I'm going to stop the sharing and then start it again. Does that make a difference?
Yeah.
Okay. 11 is a subtraction problem. I believe last class we looked at addition and subtraction where there was a common denominator already.
Mm-hmm.
So this one we could do. So with a common denominator already, what we have to do is we have to keep the common denominator. And so that denominator is, I'm sorry, I have to rearrange the screen so I can write on it. Oh, what happened there? Here we go. We're going to subtract the numerators, x squared plus 3x minus x squared minus 3. And we're going to put that difference over that common denominator, x squared plus 3x plus 2. And so when I subtract, remember you have to distribute that -1. That becomes x squared plus 3x minus x squared plus 3 over the x squared plus 3x plus 2. And so that gives me 3x plus 3 over x squared plus 3x plus 2. But I'm not done because I have to see if that's reducible. And in order to reduce it, I have to factor. That's 3 times x plus 1 over that denominator is going to factor into x plus 1, x plus 2. I can cancel out that common factor. So my difference is 3, if I can only write 3 over x plus 2. The subtraction part, all right.
Yeah.
Now, what must be excluded? What must be excluded are the values that make the denominator 0. So I'm going to factor that denominator, x plus 1, x plus 2. And when I set them equal to 0, do you see that x cannot equal -1 or -2?
Yeah.
When it says what can x not equal, what values are excluded, I'm worried about what makes my denominator 0. Better?
Okay. Yeah.
Okay, what makes this tricky is when you subtract, you have to remember to distribute that -1 to change signs and add to subtract. All right. What makes this not tricky is that it already has a common denominator. If I remember correctly, last class, we stopped short of looking at addition problems and subtraction problems where you did not have a common denominator. That's what we're looking at today. And then we're also going to look at complex fractions. So is everybody all right if I get out of the homework?
I have one more question.
Sure.
So is it only when you subtract? Do you carry the 1, or do you distribute the 1, or is it when you add and subtract?
When you add, I'm going to do a what if scenario just in the interest of time. Are you all right if this original problem was an addition sign? Oh Lord, an addition sign instead. When I add, I don't have to worry about the signs, right? So if I were to add that, I'd get 2x squared plus 3x minus 3. If I were just adding, I'd just be distributing a +1, which doesn't change it. It's when you subtract that you have to worry about it.
Okay.
Okay?
Thank you. Mm-hmm.
Thank you for asking. Can I clear? So then let's look at the outline that I put together for today. This is last class notes. This is yours. Couple of announcements at the beginning. Today we're going to look at more addition and complex fractions. I don't know if I gave you guys a heads up on the first day of class. This Friday, October 2nd, I have to go to a conference. It's a Zoom conference, but I have to go. I represent the college in this organization and I have to, participate in it. So we will not have class on Friday. Homework P6 is due on Wednesday. The problem set will be due on Friday the 2nd because the problem set is the practice test. Hopefully on Wednesday we'll have time to go through a practice test together. And so we can sort of think of Friday as being exam day, and you guys will be taking that test on your own. It will be in Zoom, and you must finish it by noon on Sunday.
Are we going to be on Zoom while I take it, or just like?
No, the test is, no, you don't have to be on Zoom while you take it. I apologize because I'm letting you take it your time frame. I meant to say that the test is in my labs, but you have to submit your work in Blackboard.
Okay, got it.
What happened was I looked at that word noon, and does anybody like it? You see the double O and you immediately think Zoom? Okay, that was just like one of those crazy senile things. So today we're going to start looking at addition and subtraction with uncommon denominators. So adding and subtracting if the denominators are different. And so the first thing that you have to do is you have to find the least common denominator. In order to do that, you have to factor each denominator. The least common denominator is the product of all the factors. From each. If there's a common factor, you use the highest exponent. So the first thing that we have to do is find that common denominator. And in order to find that common denominator, we're going to factor each denominator completely. So I'm going to start with a simple example. Let's say I have 3 over 2x plus 4 plus 2 over, did I do this example with you guys last class? 3x plus 6. Does this look familiar or not?
Yeah, we give that one.
You did that one?
Yeah.
Did we found the common denominator? Did we go through and finish the addition or not?
No, we started it, but we didn't finish it yet.
Okay, thank you. So the common denominator, this was 2 times x plus 2. I thought it looked familiar. This is 3 times x plus 2. So the common denominator is 2 times 3 times x plus 2, or 6x plus 2. And that's a 2, by the way. So then the next thing we do is we express each fraction in terms of the common denominator. In order to do that, we're going to multiply both the numerator and the denominator by any missing factors. By missing factors, I mean factors of the LCD that are not factors of the numerator. When you do this, you must multiply the numerators out. you can leave the denominators factor. Guys, need for me to wait a minute before we go back to our example.
Yes, please.
Yes, please.
Okie dokie. Let me know when you're ready. Ready?
I'm ready.
Everybody else?
Yeah, it's fine.
Okay. So our first fraction was 3 over 2 times x plus 2. Our common denominator was 6 times x plus 2. What do I have to multiply 2x plus 2 by in order to get 6 times x plus 2? The 3. If I multiply the denominator by 3, I'm going to multiply the numerator by 3. In the same way, our second fraction was 2 over 3 times x plus 2. And I want to get that denominator of 6 times x plus 2. So what do I need to multiply this new denominator by to get it? 2. That becomes 4 over 6 times x plus 2. Again, we're multiplying numerator and denominator by the same thing because what we're really doing is we're just multiplying by the number 1. We're not changing what it equals, just what it looks like. Now that we've got the common denominator, we're going to do our addition or subtraction, depending on what we're given. And then after we do that, we'll simplify if possible. And so with this one, when I take 9 over 6 times x plus 2 plus 4 over 6 times x plus 2, do we have the same denominator?
Yes.
Yes. Did we work hard to get it? Yes. So we're going to keep it. And then when I add the numerators, I get 13 over 6 times x plus 2. Very similar to what you do with number fractions, but they can get a little bit complicated. So I'm going to move class. In moving class, what I didn't do was open the chat in case somebody has a question. And now I'm going to change the page. Next example. Let's look at 3x over x plus 4 minus 6 over x plus 5. First thing I have to do is factor each denominator. Is there any work involved in factoring the denominator? I think they're both factored already. I guess what we didn't talk about on the first page that some of the homework might ask you to do is, are there values that you should exclude? What value would make that first denominator 0? I'm thinking -4. And the second one would be -5. Now we're going to come up with our common denominator. The only factor the first one has is x plus 4. The only second one, factor the second one has is x plus 5. So for my common denominator, I'm just going to multiply those two. So far, so good. So the first one where I have 3x over x plus 4, well, if my denominator is going to be x plus 4 times x plus 5, I need to multiply the denominator by x plus 5. So I'm going to multiply the numerator by x plus 5. In this one, in the denominator, I can be lazy. I'm going to leave a factor. In the numerator, I have to multiply it out. I'd have to distribute and get 3x squared plus 5x. Is everybody all right with that process?
Would it be 15x?
Yes, it would. Just looking to see if you're awake because obviously I'm not. Thank you for keeping me honest. Thank you, thank you, thank you. Next one, we have 6 over x plus 5. That one's missing the factor of x plus 4. So we're going to have to multiply both numerator and denominator by x plus 4. I'm going to keep my denominator factored, but I must multiply the numerator out, giving me 6x plus 24. Did I do a better job that time?
Yeah.
Now, they've got the common denominator. It's a subtraction problem. We've got that common denominator. I'm going to keep it. I'm going to subtract the numerators. 3x squared plus 15x minus 6x plus 24. Remember, with the subtraction, we want to think of distributing that -1. So we're going to think of that as 3x squared plus 15x minus 6x minus 24 over our common denominator, x plus 4, x plus 5. So that leaves me with 3x squared plus 9x minus 24 over x plus 4, x plus 5. So far, the subtraction part, all right. Now we have to see, can we simplify that? And now this is the first we're going to think about factoring that numerator. That numerator becomes 3 times x squared plus 3x minus 8. And let's see, 8 is 1 and 4. I'm sorry, 1 and 8 and 4 and 2. I don't think it's ever going to give me that 3 in the middle. And because that doesn't factor any further, there's no common factor. So this is going to be my final answer. How's that one?
Good.
Let's look at another one, a little bit more difficult, a little bit more challenging. Let's look at 3x over x squared plus 3x minus 10 minus 2x over x squared plus x minus 6. And the first thing we have to do is find our lowest common denominator. And in order to do that, we have to factor each denominator. So how does x squared plus 3x minus 10 factor? I'll do the hard part. X squared is x times x. What do you guys want to do with the 10? Ten would be 5 and 2. And if I have plus 5 minus 2, it'll give me that negative 10 in the back and the positive 3 in the middle. Same way that x squared plus x minus 6 we want to factor. I think with the 6, if we use 3 and 2 and plus 3 minus 2, those look all right. If so, for a common denominator, now I have to make a list of all the factors I see. From the first one, I see a factor of x plus 5 and a factor of x minus 2. From the second one, I see a factor of x plus 3. There's a factor of x minus 2, but you notice in each of my denominators, x minus 2 only has an exponent of 1. And so I only need it once in my common denominator. And so that's going to be it. Now my first fraction is 3 over x plus 5, x minus 2. What's the denominator missing? That x plus 3. So I'm going to multiply numerator and denominator by it, which gives me 3x squared plus 9x over my common denominator. Am I just talking at you folks, or does that make sense?
Yeah.
Any questions? Now we've got to do the same type of work for the next one. 2x over x squared plus x minus 6. Oh, I'm sorry. Let's leave that in the factored form. 2x over x plus 3, x minus 2. What's it missing from the common denominator?
X plus 5.
And so we've got to multiply numerator and denominator by x plus 5. I can be lazy and leave my denominator factored. Got to work the numerators out, getting me 2x squared, what is that, minus 10x. Now that they've got the common denominator,
Wait, why would it be minus 10x?
because I misread.
Okay.
Okay, thank you for keeping me honest. Now it's a subtraction problem. Actually, it's because I was thinking ahead of time. It's a subtraction problem. And so I was kind of like trying to do things in my head that I shouldn't have been doing yet. Does that make sense? We're going to subtract the numerators. In order to do that subtraction, we have to distribute that negative 1. And so when we distribute that negative 1, we're left with 3x squared plus 9x minus 2x squared minus 10x over x plus 5, x minus 2, x plus 3. And so now when we combine like terms, in the numerator we get x squared minus x. In the denominator we get x plus 5, x minus 2, x plus 3. And that numerator looks factorable, which tells me it might be reducible. I'm gonna, rather than rewriting the whole gosh darn thing again, is everybody all right if I factor it in the air up above the problem? That would factor into x times x minus 1. Does it have any common factors with the original With the common denominator? Nope. So I'm going to stop here. That's my final answer.
So if you put on the top the x in parentheses x minus 1, would it say it would be incorrect?
Look and see if those magic words are there, simplest form. I think they want that numerator multiplied out. I have to apologize. I don't remember exactly what form my labs is looking for this. I will open it on the other computer and check on that. But other than wondering whether you can leave that, I do believe you have to multiply the numerators out and leave the denominators factored. So if they want it in a different form, probably what would pop up is something that says you got the right answer, but it's in the wrong form. Multiply it out. You know what I mean? They usually give you heads up like that, don't they?
Okay.
So, yeah. So adding and subtracting, I want to say that these probably have almost more steps than anything else that we're going to do, except possibly complex fractions. So let's, if there aren't questions on addition and subtraction, let's look at complex fractions. And a complex fraction is a fraction with a fraction in the numerator or denominator. What you want to do is you want to simplify it so there are no fractions left in either. There are a couple of different approaches that you can take depending on whether you see it is the glass is half empty or half full. If you really, really want to, you could simplify the numerator. You could simplify the denominator. And then treat the problem as the fraction as a division problem, numerator divided by denominator. In my mind, that's more work than I want to do. So my favorite method, which I'll put down here as method 1, because it's my favorite. What we're going to do is we're going to first find the least common denominator of all the fractions within the fraction. So what does that mean? Let's look at an example. Let's say I have x over 3 minus 1 over x minus 3. And as I look at this fraction, I only see one fraction within the fraction. So with this one, it's pretty straightforward. My least common denominator would be 3. And so then what you're going to do next is you're going to multiply both the numerator and denominator of the original fraction by the least common denominator Sometimes we're going to write that as the least common denominator over 1, distributing where necessary. Lord, that's wordy. What the heck does it mean? Do you guys want me to wait a minute, or are we all together? We good? Hearing nothing. X over 3 minus 1 over x minus 3. I'm going to multiply the numerator and the denominator by 3. Again, because I'm multiplying them both by the same thing, I'm only multiplying by 1, so I'm not changing the value. Here, I'd have 3 over 1 times x over 3 minus 3 times 1. And in the denominator, when I distribute, I'd have 3 times x minus 3 times 3. And so that gives me x minus 3 over 3x minus 9. And now we'll simplify if possible. Does this one simplify?
I have a question.
Sure.
So when you multiply the 3 over 1 times x minus x over 3, does it cancel out the fraction?
The 3's cancel. And
Okay.
if you choose the correct common denominator, after you do that multiplication, you should have no fractions left.
How do you pick the common, how do you pick 3 as the LCD?
With this one, if I look at the terms that make up the fraction,
Yeah.
the terms that make up that fraction, we've got x over 3,
Yeah.
1, which is 1 over 1. We have x, which is x over 1. And we have 3, which is 3 over 1. So in this one, really, the only number in the denominator is 3.
Oh, okay. I'll write that down.
We're going to look at a couple more examples that are a little bit more involved. That the way you pick the common denominator is the same way you'd pick the common denominator if you were adding and subtracting.
Thank you.
Okay. So to see if we can simplify, we factor. That denominator has a common factor of 3. And so this one, you can divide out that common factor of x minus 3. And so our final answer is 1/3. How fun is that? Does 1/3 look nicer than that fraction we started with?
Yes.
I'm thinking so. Let's try another example. Is everybody ready to try another example? Ah, I have no idea why this is moving all around on me today. This time, let's look at 1 over x squared plus 2 over x minus 3 over 1 over x squared plus 1. In order to find my common denominator, is everybody all right if I think of that 3 as being 3 over 1 and that 1 as being 1 over 1? So in my denominator, I have factors of 1 and factors of x. For the common denominator, we use the highest exponent. What's the highest exponent on x? In this problem, x squared.
X squared.
Yep. So now what we're going to do is we're going to take the numerator, 1 over x squared plus 2 over x minus 3, and the denominator, 1 over x squared plus 1, and we're going to multiply both the numerator and the denominator by x squared. In order to do that multiplication, I have to distribute. Distributing, I'd have x squared times 1 over x squared. And that plain old x squared, I can think of it as 1 over 1. Plus, I'll have x squared over 1 times 2 over x. Minus, I'll have 3 times x squared. And in the denominator, when I distribute, I'll have x squared over 1 times 1 over x squared plus 1 times x. And that's step, kind of tedious. All we're really doing is we're multiplying the common denominator by each term in the numerator and denominator. So technically, we're just rewriting the problem with that common denominator next to each term. But when we do that, if we chose the right common denominator, here, let's see, x squared over x, 1 times 1 over x squared, the x squareds would cancel, and I'd be left with 1. Next product, when I multiply x squared times 2 over x, wouldn't this x cancel with the x squared and leave me with 2x? And then I've got my minus 3x squared. And in the denominator, those x squareds will cancel. 1 plus x squared. Now, to see if it can simplify, what we'd have to do is factor both the numerator and the denominator. But I'm looking at this denominator, 2 terms, squares, but it's a plus instead of a minus, isn't it? And since it's a plus instead of a minus, it's not going to factor. And because that does not factor, this is going to be our final answer. Let's look at one more. I think we have time for, actually we have time for a couple more. This time I'm going to have y to the negative 1 plus y plus 5 to the negative 1 over 5. Huh. It doesn't look like a complex fraction to me. I don't see a fraction within a fraction. Does it look like a complex fraction to anybody else?
There's a negative 1 exponent, which means the y has to be in the denominator.
Beautiful, I love you. That was the answer I was trolling for. Amazing, thank you, thank you, thank you, thank you. Exponent of negative 1 means I'm putting 1 over it. And in the same way, the exponent of negative 1 on that binomial means I'm putting 1 over the y plus 5. And in the denominator, I just have that lonely whole number 5. If we want to think of it as a fraction, can I think of that as 5 over 1? Mm-hmm. And now we have to find a common denominator between those 3 things. Does that first denominator y factor? I don't think so. So y. Does that second denominator, y plus 5, factor? No. So I need a factor of y plus 5. And so my common denominator here will be the product of the two denominators, y times y plus 5.
So in order to find the LCD, you have to find what don't, like if they don't factor, that means they're going to be the.
Yeah, if they don't factor, they're a factor in and of themselves, right?
Yeah.
So now we're going to take that 1 over y plus 1 over y plus 5 and multiply that by y times y plus 5. And whatever we do to the numerator, we have to do to the denominator. So we're going to multiply that times y plus 5. In order to do this multiplication, we have to distribute. In the numerator, I'll have 1 over y times y plus 5. And I can put that over 1 and not change it. Then I'll have 1 over y plus 5. And I'll multiply that by my y times y plus 5. And I can put that over 1 and not change its value. And in the denominator, I'll have 5 times y plus 5. And that distribution step, do you see, really, I'm just kind of rewriting it with the common denominator next to each term.
Can you go back?
Sure.
Thank you.
Let's
Okay.
wait a minute before we go further then.
Yeah.
Can I slide it up again?
Oh, yeah.
And when I do that multiplication, this first product, there's a common factor of y. They cancel out, and all I'm left with is y plus 5. There's no denominator left there. The second fraction, the y plus 5s cancel out, and all I'm left with is plus y. And in the denominator, I have 5y times y plus 5. When I go to simplify, y plus y is 2y. And then we've got the plus 5 over 5y times y plus 5.
Do you not factor that? Like, do you not distribute the 5y?
You know what? With these, rule of thumb, you know how like when we were adding and subtracting, we kind of said it's all right to be lazy and leave something like that because there's nothing to add or subtract. I'm going to leave that in factored form because otherwise I would have to factor it out in order to see if it can simplify.
Okay.
So usually they say you can leave the denominator factored. If you wanted to, you could have rewritten that as 5y squared plus 25y. But then you'd have to go through and factor it again to see if it's reducible. So, I mean, it's up to you at that stage of the game.
Okay.
Okay?
Mm-hmm.
And does 2y plus 5 factor?
No.
No. And so that's my final answer. And so those are your complex fractions. Any questions? Wow, I left out an addition and subtraction problem because I thought we would run out of time, and we've got 15 minutes left. In the 15 minutes that remain, does anybody have questions on anything that we've done today? Should we try some more addition and subtraction problems? Should we try some more complex fraction problems? Which would you rather look at, folks?
Black fraction, please.
Okay, let me grab my handy dandy old-fashioned textbook. I got a paper copy of it from, it's probably an old edition from a million years ago, but it's got mighty fine examples in it. So we're in chapter P, and we're looking at complex fractions. Ooh. Should we look at like the last one, which is probably the hardest one on the page, or should we look at a simpler one? I'll leave it up to you. How challenging do you want your extra example to be?
The hardest one. Just to like get it over with.
Okay, let's look at 6 over x squared plus 2x minus 15 minus 1 over x minus 3 over 1 over x plus 5 plus 1. And oh my heavens, I must not have an instructor's copies. The answers aren't in the margins. Let's see how we do on this one. Does everybody see this fraction contains 4 terms? 1, 2, 3, 4. To find our common denominator, each denominator. So the first fraction, anybody brave and want to tell me how you would factor x squared plus 2x minus 15?
Would it be x minus 5x plus 3?
Close. I'm thinking it might be plus 3, I'm sorry, plus 5 and minus 3.
Oh yeah, I had it backwards.
Yep, watch your signs. That second fraction has a denominator of x minus 3. Is everybody all right that doesn't factor? That in the denominator, x plus 5 doesn't factor? And 1 is 1. So looking at all of that, what do you folks think we'd use for our least common denominator?
X plus 5, x minus 3.
The product of x plus 5 times x minus 3. I like it. And since we've chosen that common denominator, I'm going to be a real little bit lazy. I'm going to, with the fraction that we have written here, show that we're going to take both numerator and denominator and multiply it by x plus 5 times x minus 3. Is everybody okay with that decision?
You did what? You did, oh, I see.
Multiply top and bottom by the common denominator. In the numerator, when I distribute, I get 6 over x plus 5, x minus 3, x plus 5, x minus 3. And I can put those over 1. Then I'll have the minus 1 over x minus 3 times that same denominator, x plus 5, x minus 3. And I can put them over 1 for multiplication purposes. In the denominator, that 1 over x plus 5, I'll multiply by x plus 5, x minus 3. And I'll put that over 1. And then I'll have plus 1 times x plus 5, x minus 3. And my hand hurts with this one. But does everybody see? All I did was I really took each of those terms and multiplied them by the common denominator. Now let's keep our fingers and toes crossed. If we did things right, something magic should happen. If we did things right, when we do each of these 4 multiplications, the denominators should cancel out, and I should have no fractions left. Here, yeah, the x minus 3's cancel. So I've got minus 1 times x plus 5. In the denominator here, the x plus 5's cancel. And I've got x minus 3. And I guess over there, because I still have to add, I'm going to multiply it out. That's going to be x squared first outer minus 3x inner plus 5x minus 15. In that numerator, I've got that minus in front of the parentheses. So I'm going to think of that as 6 minus x minus 5 over the denominator, which would be, let's see, x minus 3 plus x squared minus 3x plus 5x would be x squared plus 3x minus 18. And so now I've got 1 minus x over x squared plus 3x minus 18. And I think the denominator factors. Let's see.
I have a question.
Yeah.
Where is the 1 minus x coming from? Oh, is that when you added 6 and 5 in the numerator? Okay.
Combining like terms. Good question. Thank you for asking. The denominator would factor into x plus 6 times x minus 3. And I don't see any common factors. So we could leave it here, or we could leave it as 1 minus x over x plus 6, x minus 3. In my mind, either one of those would be acceptable. How fun was that?
Lots.
And I think that adding and subtracting and the complex fractions, both they have, you know, there's a lot of things that you have to do to complete the problem. But I don't think that one part is
It's simple. It's just a lot of steps.
right. It's a lot of running. These problems take up more real estate on a sheet of paper than you think. But please notice, I don't know about you guys, but I do not think I could have gotten to my final answer by just looking at the original problem. I have to do all of that work on paper.
Yeah.
So I don't think that, you know, I use guess and check is going to hack it with these. You really have to show your work out.
Mhm.
And I did put one on that test. I hope nobody started the problem set yet. I want to alter it a little bit because this morning I went through and added a couple extra questions to the test because I'm giving you guys a lot of extra time on it. So I want to add those couple extra questions to the problem set. So don't start the problem set before 3 o'clock today, please, 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 please. Okay?
Okay. And then for the test, it's on Blackboard, but do you want us to give all of our work and stuff? Like a quiz kind of? Like all of the work we show?
You're going to show all your work on a sheet of paper and submit it in Blackboard. And you're going to put your answers in the My Labs, the My Math Lab. Submit your work in Blackboard. If I cannot open, but don't throw it out after you took the pictures, because if Blackboard doesn't let me open it, I'll send you an email asking you to email it to me instead. All right?
Yeah.
And there's some file formats, some pictures that Blackboard will not open. I don't know. I think if you have a choice when you take your picture, I think that Blackboard likes JPG files. It doesn't like, for those pictures, it does not like PDFs, which surprised me, and it does not like JPEG. It's just JPG file. So if you have any control over how you save them, please save it as a JPG. And I promise I'll say that again on Wednesday. All right? One planned on doing is going over with the class a copy of the preliminary, the problem set, which is